So hello guys, welcome again to another discussion video with your strength of materials. Alright, so in your assessment 3, diba, after your video 3.1, which is all about stress and strain diagram and other mechanical properties. So you have your assessment 3. So your assessment 3 was all about a reading assignment of those topics kato akong i-post dito. Your Hooke's law and your Poisson's ratio. So those topics nga akong na-included tong assessment, that would be the topics that we are going to talk about in this video. So the purpose of that is to verify if sakto ba ang inyong natunan, and then you will also know kung giun sa pag-solve ang inyong assessment 3 because some is very low scores. So that is understandable since that is a reading assignment. So now for this video is ato i-verify or just to set the level of knowledge, all right, nga mao day ni ang Hooke's law and Poisson's ratio. All right, so let's proceed. So the topics that we are going to discuss here is again your Hooke's law and Poisson's ratio. So our objective here to solve problems regarding your Hooke's law and Poisson's ratio. And of course, we need to understand the concept behind these constants or topics. Okay? So Hooke's law and Poisson's ratio are still under the mechanical properties of materials in module, diba? Sa ato ang module 3. Because these values that we are going to obtain here will help us or will tell us on how strong the material is, diba, under different loading conditions. So makabalo ka nga ay weak siya or strong siya. And also you will now understand on how to use your table of mechanical properties. I know if you can recall sa inyong assessment 3, you have used a table, diba? I have required you to use your table of mechanical properties of commonly used engineering materials. So some is siguro nakabalo mo gamit because na reflect man sa ilang scores. So karon is we are going to discuss or we are going to demonstrate on how to use your table of mechanical properties. Okay? So as what we have discussed in the previous discussion video about this stress strain diagram, Ngano mayungit jud ko basta. Masa mag-stress strain diagram. Anyway, so again, based on our previous discussions of stress strain diagram, we know that most engineering materials exhibits a linear relationship, diba? So that is true within the elastic region of the material. So based sa ato ang diagram, diba? So steel, typical for steel, kasi steel man to atong gigamit nga stress strain diagram. We have two major regions, diba? We have your elastic region and we also have your plastic region. So in this region, okay, base a figure, in this region, the maximum limit is called as our proportionality limit. So sa ko pag-iingon before, ang sa steel usually is si proportionality limit, si elastic limit ug si yield point is usually makit-an na sila sa isa ka puy tungod dugol naman gugay na siya. It's hard to detect. Pero in reality, the maximum limit for our elastic region is our elastic limit. Pero para proportion, katong proportion gihapon sila, like the stress is proportional to the strain, so and the limit would be your proportionality limit. So meaning up until this point, our stress and strain are proportional to each other. So what does it mean? Meaning is an increase in strain is an increase in stress and vice versa. So kung mo decrease si strain, mo decrease pod si stress. So in relationship, stress alpha strain, diba? Alpha is meaning proportional sila. So stress is proportional to the strain, or in designation, that would be sigma is proportional to our epsilon. All right. So this relationship about stress and strain within the elastic region of different materials was discovered by Robert Hooke in 1676. So I'm not sure if you have discussed this sa inyong physics, pero sa under na ko sa physics is ako na siya gi-include. And I guess siguro sa statics pod, I have introduced this, that the force in the spring, di ba? The force in the spring is equal to, if we have Fs for example, wait, di ba? That the force in the spring is equal to your Ks. Di ba? That is the formula in finding the force exerted by the spring. So, if you can recall this is our called as the Hooke's law, di ba? By physics, this is our called as our Hooke's law. So, your K here, right? Kanang K na to, di ba? That is called as our spring constant, or that is our spring stiffness. And your S, that is your deformation of the spring. So using the same concept, all right? Using the same concept, di ba, your stress is a function of force. Okay, your stress is just simply force over area. So pwede ni siya himuon nato nga stress pod. And also your deformation, di ba, your S here is your final length minus your original length. Di ba, that is just simply equivalent to our delta. Di ba, mura siya delta lang yun gihapon sa ato final minus original. So, your S here can be related as a function of a strain. Pwede na to siya himuon niya strain. Di ba? So, therefore, we can relate. Okay? We can relate your stress and strain using, again, the concept of Hooke's law. So, applicable lang yun gihapon na siya. So, nalantay constant diri something, right? Nalantay constant diri, say, constant or C. Let me put that as C. Okay, wala pa man ta mag-derive, alright? So, your stress is equal to your strain multiplied by a constant. So, unsa na siya nga constant? So, if we recall algebra, di ba, linear variation man na siya. Basta naaga ni alpha, ug imo na siya i-convert to equal sign, taparan lang nimo siya og constant, di ba? Taparan lang nimo siya constant. So, if this would be our strain, that would be equal to a constant multiplied by our strain. So, kinsa man siya constant? Pwede na nato siya ako lang siya move, di ba? This would be E multiplied by your epsilon, di ba? Ang alpha nato, since proportional man sila, ato siya alisdan og equals with a constant of variation. Ginatawag nato siya as constant of variation or constant of proportionality. Naitawagan na niya. Okay? So, mathematically, this relationship can be expressed as sigma is equal to E multiplied by your strain, or stress is equal to E multiplied by our strain. So, where E represents the constant of proportionality, and it is known as the modulus of elasticity. And also, this is called as Young's modulus because it was published by Thomas Young in 1807. So, Young's modulus or modulus of elasticity is denoted by capital letter E. Okay? Capital letter E. So, malang siya. This is your Hooke's law. So, using this equation, alright, using this equation, we can manipulate this one to somewhat mas dali siya hinumduman. Pero, again, actually, mo na ni ang concept ni Hooke's law. Mo lang gini siya. So, pwede na ka musulong og gira nga kanira imong dala. Alright? Musulong ka og gira sa module 3 nga kanira ang imong dala. Diba? Pero ako, I tend to forget this formula nga nakaingon ani. Diba? I tend to forget this one, especially way back college. Kay maglisod si ikog memorize kung tapad-tapad. So, medyo maglisod ko og remember if nakaingan na siya porma. Muna, I always use this formula of E as a slope of the stress strain diagram. Unsay pasabot ni mga slope, sir? Because your slope, diba, is simply rise over run, or your vertical over your horizontal. So in this case, using your stress strain diagram, your rise is equal to your stress and your run is equal to your strain. Diba? So, your stress over strain, ako lang siya i-manipulate ng equation. Ako i-divide by the strain diri. Diba? Divide by the strain. So, therefore, our E is just simply the slope of the stress strain diagram in the elastic region. So muna akong sana prefer nga formula for your Hooke's law. Kay mas dali ko maka-memorize og naka-fraction man god. But depende sa inyo ha. Alright, basta sa ako pag-ingon, kani pa lang is pwede na ni siya. Alright? It will work na good. Okay. So let's proceed immediately to our example. So the strut is supported by a pin at C and a bronze C86100 guy wire AB. So this is our okay. So this is our guy wire. Has a diameter of 6.6 mm and with the W is 2.8 kilonewton per meter, which has the length of 3.437 meters. So the weight here would be 2.8 kilonewton per meter. So this has a diameter of 6.6 mm. Okay, so marami siguro na ang given. Okay. So let me just simplify this one. Okay, let me just simplify this one. Especially your what? Especially your distributed force. I can simplify this by dali ra kina ninyo. That should be 1/2 of the base times height area. 1/2 of the base, which is 3.437. The height is 2.8 kilonewton per meter. So that would be my resultant force. That should be 4.8118 Newton. Diba? That's 4.118 Newton. And our distance here would be okay, so our distance here would be what? That should be 3.437 divided by 3. 3.437 divided by 3. That should be equal to ano na lang, ako lang siya fraction. That's 3.437 divided by 3. That is in meters. Okay, that should be equivalent, approximately equal to 1.146 meters. Pero para whole number or whole value akong magamit, ako lang siya fraction. Okay. Siguro mo na lang siya, so maybe we can proceed to a larger nga screen. Okay, so great. Okay, so based on the figure above, below, below, so naatay, let's do the free body diagram. That is pin at A, diba? That is pin at C. Medyo di ko klaro. So wait sa. Okay, so kinana. Let me just enlarge this one. Okay, so we have here pin at C, diba? So statics gihapon, we will be having here your CY. We will have here your CX. Dire we will have if this is 60, this would be 30, diba? That would be 30. So since this cable here is a two-force member, meaning duha ra ka force ang iyang gina-experience diha. Unsa man ang two force diha, that would be your ABY and your ABX. Okay? ABX na siya. Your ABY is just simply your AB sine 30. Diba? And your ABX here would be AB cosine 30. So, para ma-solve na ko sa AB, since we are concerned with the force, because again, we are talking here about we need to solve the deformation. Diba? We need to... Wait. Diba? We need to determine how much it stretches when the distributed load W acts on the strut. So, anyway, let's proceed with the solution na lang para mas makagets. Okay? So, we need to find here the force acting on this strut because yaman atong concern ng iyang elongation. Okay? So, that would be AB sine 30. To solve your AB sine 30, we can use moment at C. Diba? We can just have moment at C. So, summation of moment at C is equal to 0. Your clockwise moments are positive. So, kung sa may mga clockwise moment, we have your 4.8118 multiplied by the distance, which is 3.437 over 3 para whole value. Then, minus, since this is negative, that should be negative AB sine 30, and the moment arm is 3.437, and that would be equal to 0. Kaya naman, si CX o si ABX will not moment at C. Okay, of course, mulabay man na siya. Very basic knowledge for moment. Okay, so using this equation, we can have the force acting at force at cable AB or wire AB. So that would be 4.8118 multiplied by 3.437 divided by 3. Then divided by 3.437 sine 30. So the force acting at force AB is 3.2078667. That is in kilonewton. Diba? So let me just convert this to Newton. Mahimo ni siya nga multiplied by 1,000 para mas madali. That would be 3207.86667 Newton. Para sure ako siya i-store ni A. Okay. So, I have already the force at AB. So, we can now, saan natin pag-determine ang iyang elongation. So, let's play with the Hooke's law. Hooke's law, magigihapon ta magsugod. So, your Hooke's law is just simply your stress over your strain is equal to your E. Now, your stress, that would be your force AB multiplied by the area of wire AB. Diba? Tapos, your elongation or your strain, that is just simply your deformation divided by the original length. Diba? Mo man siguro mo na, di man siguro ta maglitsod og memorize ani, diba? Your stress is equal to force over area. Your strain is equal to deformation divided by the original length. So FAB na natay value ni FAB, di ba? Your FAB is equal to naa ni A, di ba? Naa ni A naka-store. So naa ni A, ako lang siya butang diha. Then your area is just simply your 0.25 pi d squared. What is the diameter of our wire? That is 6.6. Tara. That is 6.6 millimeter. So 6.6 squared. Now, what is our deformation? Deformation is, again, that is our unknown. Mamigay pangita. Determine how much it stretches when the distributed load W is applied. So, that would be our unknown. Si deformation or our delta. Your original length can be solved using what? You can solve that using Pythagorean theorem. Diba? Using trigonometry. So, your original length si 60, yun na may 60 dire. Si 3L is unknown, so that is opposite. So, we can use your sine theta or sine 60 is equal to your opposite over your hypotenuse. Now, in this case, our opposite would be your 3 point, kinsa man? Our opposite would be your 3.437, di ba? 3.437. Then, the hypotenuse would be our LO. So, may LO, that is the original length of your AB. Katong wala pa siya load. Meaning, original length, wala pa siya may deform. Diba? So, therefore, our LO is equal to 3.437 divided by sine 60. 3.437 divided by sine 60. So, whatever value in that, I will store that to B. Para mas madali. That should be 3.437 divided by sine 60. Ako siya i-store ni B. So, that would be approximately equal to 3.969. So, muna approximately dito ako gamit because I don't round off manggod sa solution. So, I store values para mas buo siya. Okay? So, nanatay value ni LO. So, that would be delta over your whatever value nga naa ni B. So, nanatay stress, nanatay strain. So, how are we going to find for the value of E? So, nga rin nata magamit sa ato ang table. Diba? Table. So, dirita sa ato ang table. So, ang ato ang material nga gamiton daw is, unsa? That is bronze CH6100 guy wire. So, material would be bronze CH6100 guy wire. So, ang atong pangitaon diri would be a material that is made of bronze CH600. So, wrought iron, wrought alloys, cast iron, copper, magnesium. So, copper na siya sa bronze. So, bronze CH6100. Di ba? So, we need the value of your modulus of elasticity. Kung sa may value niya. This is in US customary, so English system, but since again we are talking here with mm and kilonewton, so naata sa metric. So metric ta as a unit. So bronze CH600, what is our modulus of elasticity? Diba dara diri? That is our modulus of elasticity. That is 103 gigapascal. Okay, so that is 103 gigapascal. So now we can proceed to our solution. We will be having a value of E which is equal to 103 gigapascal. Pero, para mas madali, okay, your B is in meters ni siya, no? So, I'll be multiplying it by 1,000 para mahimo siyang mm. So, B multiplied by 1,000. So, our LO would be equal to 3968.705 mm. Kaya nga ako man siya i-convert to mm, unyang ako ang force is ako siya i-convert to Newton. Diba? Naka-Newton. Kaya again, para ang ato ang result nga stress over strain would be in megapascal. Diba? Para megapascal. So, therefore, our working equation would be your A, whatever value nga naan A, divided by the area which is 0.25 pi 6.6 squared, diba? This term here would be our stress divided by our strain which has a value of delta over your whatever value nga naa ni B. So, stress over strain, this is in Newton divided by mm squared, so that would be in megapascal. This would be unitless. Diba? Unitless. Kaya magawas karon diri nga deformation would be in millimeters. So therefore, if this is MPa, this would be equal to your 103 that must be converted to 103,000 megapascal. Diba? Okay, so you can use shift solve if you want. So manipulate the equation. You can solve a deformation in millimeters. Okay? Ang gawas karon diri would be in millimeters. So, that would be A over 0.25 pi times 6.6 squared. Then, divided by your X over naa ni B. And that would be equal to 103,000 megapascal. So shift solve. Okay, so wait sa tanong. So our deformation would be 3.613 millimeters. Okay, so mo naman na siya. That is the stretch. Since positive may nigawas, meaning ni-increase ang ato ang or ni-elongate. Ni-elongate ang ato ang wire AB. Okay, so I guess mo na siguro ng answer. So let's check if we have the same answer or we have the correct answer. So the correct answer is 3.613 millimeter. So we have the correct answer. Okay? So ina na lang siya. I hope na nakagets na mo kung how to solve your problems involving Hooke's law. Okay? So for the next problem, a bar having a length of 124 millimeters and a cross-sectional area of 655.2 square millimeter is subjected to an axial force F is equal to 120 kilonewton. If the bar stretches 0.556 millimeters, now we are going to determine the modulus of elasticity of the material. So the material has a linear elastic behavior. So meaning that is just simply on the elastic region. So therefore, Hooke's law is applicable. Okay, so pwede gitag na rin na lang. Your working equation would be your umaya ka na. Okay, so we have ano man siya? Masugod ta balik sa ato ang Magsugod ta balik sa ato ang Hooke's law. That would be your stress over your strain is equal to your E. So muna itong working equation. Let's start solving for our stress. Your stress is just simply equal to force over area. Your force here is 120,000 Newton. Diba? Ako siya in Newton. And the area would be 655.2 square millimeter. So the resulting unit would be in megapascal. So whatever value in that, you can just store that to A para din leta makasave tag space. So that would be in megapascal. So 120,000 divided by 655.2. So that would be 183 megapascal. So ako na store to A. And then for our strain would be nga rin na lang sa ubos pod. That would be the deformation over the original length. So our deformation daw is 0.556. Diba? That's 0.556. And the original length is what? 124 millimeters. So therefore, what is our strain? Ako lang siya i-store ni B para buo gihapon. So the unit is in millimeter per millimeter, so dimensionless. So 0.556 divided by 124. So that would be 4.48 times 10 to the negative 3 or 4.48 micrometer per millimeter. So anyway, I'll just be storing that to B. Kay para ang ako ang ikaron is very simple lang. That would be your stress over strain. So that would be whatever value nga naa ni A divided by the value nga naa ni B. So ina na, right? Inga na kasimple ang imuhang Hooke's law. So that would be A over B. And kung unsay unit nga naa ni stress, mao pud na ang iyahang sundon. So since naka-MPa man ni siya, MPa pud ang gawas ani niya. That would be 40,846.44. So medyo dako raman siya. I'll just be using gigapascal. So I'll divide this by 1,000, mahimo ning 40.85 gigapascal. So that would be our final answer. So let's check if we have the same answer. Yeah, that is 40.846 gigapascal. So, ano siya? That is just simply the whole topic with regards to your Hooke's law. Okay? So, now, makaingon mo nga is just a basic substitution, di ba? basic substitution lang gina to the formula of your Hooke's law. So no need for you to sana siya ma-worry siguro. Okay, bonus na siya ka topic. Okay, so our next topic is all about your Poisson's ratio. Okay, so in the previous video, I have placed a link in the description, diba, for you to fully understand the concept of your Poisson's ratio. So sa mga wala pa, I placed it again sa description below. Char, YouTube na YouTube, diba? So, so mo to siya, mas klaro to siya, alright? Mas klaro to siya nga pagka-discuss, especially with animation man gud to. So, just watch na lang para mas na idea or para ma-understand yun ang concept. Okay? So, this is formulated by French scientist Simeon Denay Poisson. Basta na dito sa video, unsa yun sa pagka-pronounce. French. So, medyo French, di na to kaya. Alright? So, the concept of Poisson's ratio is simple logic. Ang simple logic nga itong mahimduman diha would be is, kalagi na kay lastiko or guma baka. Alright? Diba, if imo inaton ang guma is, diba, if you pull the rubber too hard, is mo elongate siya. As long as dili pa siya maputol ha. As long as dili pa siya maputol, mo elongate siya. Right? Mo taas siya. Pero, simultaneously, munipis pud siya. Diba? Munipis pud siya. So, that is the concept of your Poisson's ratio. And also, for example, another example is a sponge. Or a rubber. For example, kani, the same sa figure. Diba? If imo duoton ang sponge or rubber, nga dako kayo nga rubber, diba? Mumubo siya, right? Mo contract siya, pero ang isa ka dimension is mo widen or mulapad. So, that is just simply the simple logic to relate to Poisson's ratio. So, unsa may gid ang Poisson's ratio? Ang iya diha is within the elastic range, the lateral and longitudinal deformations are proportional. Okay, so as long as daw dili pa siya mulapas sa iyang elastic limit, meaning if you remove the load, mubalik paghapon siya sa iyang original shape and dimensions. So, within that range, sa ato ang elastic range, Poisson's ratio is still applicable and true. Now, let's identify first, para di mo maglibog, let's identify first what is the longitudinal deformation and what is the lateral. Okay, so mayong kitag longitudinal, yung damilan ni siya, longitudinal is parallel sa force. Right? Parallel to the force. While si lateral, of course, that is the side or the length that is perpendicular to the force. Now, for example, alright, for example, if I have a force that is parallel to the z-axis, alright, if I have a force parallel to the z-axis, the length that is, or the dimension along the z-axis, that would be my longitudinal length. And the lengths along x and y, alright, are my lateral lengths. Anyway, you will understand that later if we will be having some examples. Okay? So again, according to Uncle Poisson's chart, okay? So according to Dennis Poisson, that as long as the material is within the elastic range, diba? Siya pag-iingon, the deformation in both axial or longitudinal axis and the lateral axis are proportional. So, if proportional gani, right? If proportional gani ang ato ang deformation, ang ato ang stress o ang ato ang ang ato ang mga strains, diba? Natay duha, the lateral and the longitudinal. Now, the deformation in both axes are proportional. So therefore, if they are proportional, the strain nila duha pod are constant since function ra man gihapon sila sa deformation ang ato ang strains. Okay? So therefore, kaning nga constant, di ba? The ratio between the strains in the lateral and the longitudinal nga mga strains, they are constant. Now, kanang nga constant, that is denoted by the Greek letter nu, right? That is nu, marashag V, and that is called as your Poisson's ratio. So, ratio lang na siya sa ato ang strain along the lateral axis and the strain over the strain along the longitudinal axis. Okay, so mathematically, Poisson's ratio can be expressed as your lateral strain divided by the longitudinal strain. Okay, so negative. So considerations daw is within the elastic range, homogeneous, and isotropic. So have I said, answer na siya? Anyari sa'yo, sir? So, as I have said, di ba, a while ago, that ang consideration nato for Poisson's ratio is dapat within siya sa elastic region. So, ako na siya balik-balik ganina. And also, ang usap pa consideration for Poisson's ratio is the material should be homogeneous and isotropic. So, when we say homogeneous, meaning uniform siya, like the same material all throughout. So, dili siya composite. So, concrete, example, concrete, si concrete lang itself, plain concrete lang gid na siya, that is homogeneous. Pero if mahimo na siyang reinforced concrete, meaning composite na siya, na siya concrete na pag siya kabilya, which is the commonly used structural na system sa ato ang dire, so dili na siya non-homogeneous na siya. Alright? Basta uniform material na siya, gitawag na siya homogeneous. So di siya applicable sa mga composite material. And for isotropic, when we say isotropic, meaning all the properties is the same at any side of the material. So, best example of a non-isotropic, meaning dili siya isotropic. So, meaning si wood is dili siya pwede sa Poisson's ratio. Ano naman, your wood is a non-isotropic material. Ano naman, because if you are going to research about wood or lumber, ang iyahang strength, siguro naman siguro yung background on your building tech about wood, diba, material. So, si wood, its strength is not the same at any sides. So, ano man, the wood is stronger against the grain. Diba naman yung mga grano sa kahoy? So, if against ka sa grains niya, right, against the grain, that would be stronger. Pero if along the grain, the wood is weaker. So, muna nga, dili pwede ang wood since dili man siya isotropic. So, ang pwede lang sa Poisson's ratio is isotropic, meaning same property all throughout its member or faces. Okay? So, probable values. Alright? Mo doon ang mga probable values for Poisson's ratio. So, less than 1. So, na 0.25. Okay? So, na-include na ni siya sa video kanana sa description nato. Alright? Na siya sa video nga akong ipakita ang mga different na probable values. So, nasa ganit dito ang mga values nga nasa sila negative Poisson's ratio. So, kung ano negative, try to watch na lang sa video aron mas makagets. Negative siya, meaning, mo increase gani si lateral strain, mo increase pod si longitudinal strain. Because in reality, some of our natural materials are, kung mo elongate siya on the other side, mo contract po siya on the lateral sides. So, mo yun ang reality. Mo na ang positive. So, back in the formula, ngano na ay negative. Munta ko giingon ganina nga na siya negative kay, for example, sa ako example ganina, rubber, di ba? Or sponge. When the other side contracts, the other side elongates. So, vice versa. Kung mo elongate po ng pikas, mo contract po ng pikas. So, therefore, the positive deformation on one side, kung mo elongate siya, positive man, di ba? So, the positive elongation on the other side is a negative deformation on the other side. So, mo elongate siya sa pikas, mo contract siya sa pikas, so negative. So, muna, nga naa siya negative nga sign to make the constant a positive. Right? Ma-positive siya. Kay negative, sa lateral. Mo elongate sa lateral, so positive. So, mo contract man siya sa longitudinal, so negative ni siya. Negative ang ilahang ratio. So, para ma-positive si Poisson's ratio, na siya negative nga naka-attach para ma-positive ang constant. Okay, so, sa padaya. Again, guys, some of the points that I've been telling here was already discussed na sa video. So, tanan ako gipang story about Poisson's ratio is murag naka-state na siya dito sa video. So, para mas clear ang discussion, especially if ganahamog na yung mga animation, so, I prefer nga tumutanaw sa video. Diba? So, the table also that I have, ito nang gigamit ganina sa example is, nana po dito si Poisson's ratio. It also contains the Poisson's ratio of your commonly used engineering materials. So, depende kung unsang materials imong gamiton. Okay? So, dara. This is for your English system, diba? That is your Poisson's ratio. And for your metric system. Kana siya. So, since Poisson's ratio is a dimensionless quantity, kay ratio raman siya sa strain, duha ka strain. So, dimensionless siya. So, obviously, they have the same value in both system, English and your metric. Okay, so these are the other mechanical properties. So, first is your ductility. So, ductility daw is the percent elongation reported in tensile test. And it is defined as the maximum elongation of the gauge length. So, imagine na lang, your ductility, that is simply how you report your result. Diba? Example, nag-tensile testing ka. So, ang result sa tensile testing is gina-report na siya, alright? Gina-report na siya in terms of ductility or percent elongation. Kita mo siya percent elongation. So, ano siya? Percent elongation. Next is dilatation. So, that is denoted by small letter e. That is the change in volume per unit volume. So, that is also called as your volumetric strain. Okay, diba? We know that if a force is applied or a stress is applied along the, example, x-axis, for example, diba? The length along the x-axis will not be the only strain that will occur. Okay, base sa ato ang Poisson's ratio, na po strain nga ma-experience si y. Sorry, dito COVID. Okay, so, if we are going to apply force along x, si y o si z will also experience lateral strains, di ba? By Poisson's ratio, man na siya. So, therefore, during application of load, all dimensions may change, di ba? So, since all dimensions have changed, therefore, everything has changed by Taylor Swift. Char. Okay, so, including the volume, di ba? Kaya mo change ko ang dimension. So, therefore, if may change ang dimension, mo change po na nga to ang volume. So, therefore, we can also solve the change in volume using the formula for dilatation. With the formula, your change in V over V, that is equivalent to our E, or volumetric strain, that is equivalent to your strain at X plus your strain at Y plus your strain at Z. So, muna siya. That is simply your formula. So, if nanakay strain, alright, if nanakay strain along the X, the Y, and the Z, you just have to add it, and then that would be the value of your volumetric strain. Okay, so I hope that's clear. Okay, so for example, okay, that is uniaxial stress. For example, we have this rod, diba? We have this rod and has a tensile force P na gina-apply, diba, natay force P diha. Let us say the force is acting at the x-axis. Na siya sa x-axis nag-act ang ato ang force. So therefore, the length kaning nga L, right? That is my longitudinal or axial length. Ngano man? Diba nganong CL man ang longitudinal axis na to, sir? Kay that your x is, or your L, that is again parallel to our force. Diba? Since si X is na, since si P is na sa x-axis, and then si L po is na po siya sa x-axis, therefore, L is our longitudinal or axial length. Diba? Now, therefore, ang nahabilin, your length at Y and your length at Z, they are my lateral lengths. Right? Lateral lengths. So, in this case, since rad man ni siya, right? Rad man ni siya, they are both equal to the diameter. Diba? Diameter diri, ang iyang Z, tapos diameter pag gihapon dito sa Y, so the same siya. Pero if prismatic, lahi-lahi na siya, na siya length, na ay width, na ay height, diba? If a rectangular prism ang forma. Pero since this is a cylinder or rod nga forma, so your lateral dimensions are equal to the diameter. So that is the one thing that I want to emphasize regarding your Poisson's ratio, that the first step good in solving this type of problem is you have to identify who is the longitudinal dimension and what are the lateral dimensions. Importante yun na siya. Okay, again, your Poisson's ratio is doing your lateral and your longitudinal na strain. So, dapat kabalo ka ma-identify kung asa si lateral, asa po si longitudinal. Again, mas malipat mo because some references are using axial strain that is just simply equivalent to longitudinal. Again, axial is equivalent to longitudinal. Axial or longitudinal, pareha na siya. Okay? So, again, this formula of Poisson's ratio, this formula of Poisson's ratio is only applicable for uniaxial stress. So, tawag siya uniaxial stress. Nga naman, when we say uniaxial, that is just when only one side is applied with force. Meaning, di ba dere, ako sa raka side ang naay force or ga-experience of stress. So, all the other strains are just caused by a single axial force. So, walay force acting on the lateral direction. Munang ginatawag siya og uniaxial stress. Okay, so again, this is the formula on finding your Poisson's ratio, di ba? So, let us just derive the formula on how to solve the deformation or the strains on the both axes, sa tanan nga mga axes. Alright? In X, Y, and Z axis. So, unsa may importante? Unsa, di ba? Unsa ka importante nga mag-solve ta sa strains? Because again, if you have the strains, you can visualize the change in dimension. Di ba? Makabalo ka nga, ni mubo siya, ni taas siya. So, if you also solve for the strains, ma-solve po nimo kung ang volume is migamay ba, di ba? Or the change in volume mi mubo ba siya or mi dako ba siya? So that is also the importance of solving for the strains. Okay, so example, kani siya the same gihapon. We have here your rod. Sorry. Your x-axis would be your longitudinal axis, di ba? So the first data that you can solve here is the strain along the longitudinal strain or longitudinal axis. So, di ba, this is our Poisson's ratio. So, ang imo jud, since si P is na sa x-axis, automatic automatic kani mahimo na to nga longitudinal axis. And the other two axes would be your lateral axis. So, kung asa ka nag-apply sa force, automatic, masolve na yun mo ang imuhang or the strain along the longitudinal axis. Right? The longitudinal strain. So, how to solve your longitudinal strain? Diba using the concept of your Hooke's law, your stress over strain is equal to your E. So, manipulating the equation, your strain is just simply equal to your stress over your modulus of elasticity. Di ba? Your modulus of elasticity. Now, in this case, right, since your longitudinal axis is si X, di ba? So, mahintabo ni siya, mahimoning, your strain at X is equal to your stress at X over your E. Di ba? So, obviously, this would be our strain at X. Gunsa ni pa-solve si stress at X, sir? So, simple. Di ba? Your stress is just simply force over area. So, the force P, then the area of your rod, the cross-section of your rod. Kaya naman siya nag-apply. Di ba? So, stress lang yun na siya, basic nga stress. Alright, so since we already have your AX here, or your strain at X, we can solve your stress at Y and strain at Z. So, using your Poisson's ratio. Di ba your Poisson's ratio is equivalent to your negative? Ang ato ang lateral say X, ay Y. So, your strain at Y is equivalent to our strain at the longitudinal axis. Now, our longitudinal axis here would be your X. So, this would be our strain at X. So, solving your EY, solving your strain at Y, that would be equal to strain at Y is equivalent to negative Poisson's ratio multiplied by your strain at X. So, substituting the value of your strain at X, that would be negative V Poisson's ratio multiplied by your sigma X over your modulus of elasticity. Okay? So, since the zero naman sila mga value, your EY, that would just be equal to your strain at Z. Diba? The same nagigihap na sila nga value. So, therefore, your strain at Y and Z are equal as a function of our Poisson's ratio and your strain at the longitudinal axis. So, mo ni siya. This is how we find the strain at the lateral axis. O, diba? Mura na siya og that is just simply the application of your Hooke's law to your Poisson's ratio. Just to relate your stress and your strain. So therefore, this is how we find the lateral strains in a material under a uniaxial stress. Oops. Sorry. So, kana siya. That is the formula in finding your strains. Okay, so now let's proceed to our example. So a bar made of A36 steel has the dimension shown. Now, if the applied force of 80 kilonewton is applied, let's determine the change in its length, and the change in the width, the change in height, and the change in volume. Now, assume that the material behaves elastically. So, meaning, your Poisson's ratio and your Hooke's law is applicable. Okay? So, sa kapag yung ganina, the first procedure that you need to do is you select who is the longitudinal axis and who is the lateral axis, di ba? So in this case, since prismatic man siya, we have a length of si length nato is na ani z-axis, di ba? Z-axis, that is 1.5, ako lang siya AMM ha. That is 1.5 millimeter. Now we also have your width, that is along x-axis, that is 100 mm, and the height is along the y-axis, that is 50 mm. Okay, so since if P, diba, your P is parallel to the what axis? Your P is parallel to the z-axis. Therefore, automatic si length would be my longitudinal. Diba? That would be automatic my longitudinal. The rest, that would be my lateral length. Diba? So, ano na siya. So, maybe now we can proceed to our solution. Okay, so first is we need to find the Poisson's ratio. We have your A36 steel. We have your A36 steel. So therefore, your E is automatic. That would be 200 megapascal. And your Poisson's ratio is, pilay Poisson's ratio sa A36? 200 gigapascal sa sakto. Okay. 200, and that is 3 data. Okay, so your Poisson's ratio is ato kitaon. Your Poisson's ratio is that is 0.32. Yeah, so 0.32. Okay, so we have here your 0.32, so wala na siguro need. Okay, so that would be 0.32. Okay, so how to solve your this problem using your Poisson's ratio. So, very basic. Let's start with your EX. Human ito pinakauna nga z-axis day. Z-axis. So, our longitudinal, imagine pinakauna nga ma-solve diha would be your longitudinal nga mga properties. Diba? So here, ang longitudinal axis would be your x. So therefore, we can solve your your strain at z is equivalent to your stress at z over your E. Now, how to solve your stress? Wala mo siguro kinahanglan. Sige, later. Your Z, LZ is equal to 1,500. Your LX is equal to 100. And your Ly is equal to 50. Okay. So, we can solve your stress at Z. The force applied is pila daw. The force applied is 80 kilonewton. So, that would be 80,000 Newton. Then, the area would be... Sige daw. Una-una pag maayo kung unsa ang area nga gamiton. Okay. So, diha nga figure, what is the area that we are going to use? Of course, that would be 100 by 50. Diba? That should be 100 by 50. So, medyo, kung imo siya imagine that is just simply the area comprises the lateral dimension. Diba? Comprises the lateral dimension. So, therefore, our area would be 100 multiplied by 50, and the unit is in square millimeter. So, is equal to 80,000 divided by 100 times 50. So, that would be 16 mega Pascal. So, therefore, we can now solve your strain at Z. That would be equal to 16 megapascal over your E, which is equal to 200,000 megapascal. Again, basta nag-wonder mo kung di na ako gipangita na siya sa ato ang table of mechanical properties katong naa sa PDF nga akong gina-attach. Right? So, makancel si MPa. So, therefore, our strain at Z is equal to 16 divided by 200. That would be 8 times 10 to the negative 5. So, positive, that is positive. Kaya nga naman, tensile man siya. So, ang ato ang stress derivative is positive, diba? Kung compressive force, negative ni siya. Pero if tensile force, so, positive. So, since positive man ni siya, this is a elongation. So, if we already have the strain, later na lang, ato sa humanuntanan strain. So, we can solve the value of our strain at X. That would be equal to the strain at Y, which is equivalent to your negative Poisson's ratio and the strain at Z, which is equal to negative 0.32 multiplied by your EZ, which is 8 times 10 to the negative 5. So, that would be equal to times negative 0.32. That is equivalent to negative 2.56 times 10 to the negative 5. Since negative man na siya, meaning this is a contraction. Contraction ha, nag-contract siya. Okay. So, since we already have the strains in all axes, we can now solve for your change in dimension. Let's start with the change in length. Diba? That is the first question. Change in length, change in width, and your change in height. So, your change in L is we are concerned with your z-axis because that is our LZ man. Diba? LZ. So, therefore, your EZ is equal to your deformation at L, or your deformation of the length, or the changing length, divided by the original length. Now, what is the original length of our EZ? So, LZ. So, that would be 8 times 10 to the negative 5. Ako na dili na lang. Ako na siya i-manipulate diretso. So, that would be your deformation at L is equal to your strain at Z multiplied by your length at Z. So, therefore, this would be 8 times 10 to the negative 5. The original length is 1,500. The unit is in millimeters. So therefore, what is the change in length? That would be 8 times 10 to the negative 5 multiplied by 1/5. That is equal to 0.12 millimeters. Then for your change in height or width na lang, change in width, that is our width is concerned na to is si x. So that would be the strain at x multiplied by your length at x. So that would be negative 2.56 times 10 to the negative 5. Your length, original length at x is 100. Okay guys, ako lang siya gidiretso ha. Ako lang siya gidiretso. Pero again, nag-base gyapon na siya diri sa ato ang strain nga formula. That strain is equal to your deformation or your change in length over your original length. Okay, so ako lang siya gi-manipulate, ako lang siya gidiretso substitute dire. You can try that. Okay, so therefore your change in W or your deformation at the width is negative 2.56 times 10 to the negative 5 multiplied by 100. So negative siya, meaning mas nimubo siya. Right? Mas nimubo siya. That would be negative 2.56 times 10 to the negative 3 millimeters. Now, for your change in height, which is in this case, we are using your strain at y, diba? Your y-axis, your height, yeah. So that would be your strain at y multiplied by your ly. So this would be negative 2.56 times 10 to the negative 5 multiplied by your ly, which is 50. So therefore, your change in width, your change in height, is equivalent to negative 2.56 times negative 5 times 50. That would be negative 1.28 times 10 to the negative 3 millimeters. So the same gihapon, negative kay may contract man siya, which is true. Kaya kung mo-elongate ang pikas, ang duha ka lateral axis would reduce or mo-contract po siya. Okay, since we already have the last question is your D, your volumetric strain or your change in volume. Since we already have the three strains at the axis, we have your strain at Z, your strain at X, and your strain at Y. We can solve the change in volume. Unsa man na siya, sir? First is we need to solve for your dilatation or your E. That is just simply your AX plus your strain at Y plus your strain at Z. Your strain at X and Y is the same. That would be duha ka 2.56 times 10 to the negative 5, diba? So ako lang siya i-multiplied by 2 kay equal ra man gihapon sila. Then plus your 8 times 10 to the negative 5. And that would be our dilatation or your volumetric strain. So that would be duha ka negative 2.56 times 10 to the negative 5 plus 8 times 10 to the negative 5. So our volumetric strain would be 2.88 times 10 to the negative 5. Since strain man ni siya, unitless gihapon ni siya, so this would be our E. And again, if you can recall, this is equivalent to your change in volume over the original volume. Diba? So, original volume. So, therefore, our change in volume is equivalent to your original volume multiplied by the dilatation. So, how to solve the original volume? Very basic. That is just simply your length times width times height. So, that would be 1/5 times 100 times 50. Diba? That is the original volume. Then, multiplied by your dilatation, which is 2.88 times 10 to the negative 5. So, what is our change in volume? 1/5 times 100 times 50 times 2.88 times negative 5. That would be 216 cubic millimeter. Kay cubic millimeter naman ni siya. So, therefore, this is our change in volume. So since positive man siya, so therefore ang ato ading volume is may increase due to the applied force, di ba? Due to the applied force which is 80 kilonewton, ni-increase ang ato ang volume. You can check that if sakto ba ang atong change in volume. You solve for the final volume dire, alright? So to solve for the final volume, para ma-check lang nato if sakto atong volumetric strain. The final volume is equivalent to your final length multiplied by your final width multiplied by your final height. So our final length, kung saan man pagkita sa final length, ang ato ang length daw is may increase og 0.12 mm. Diba? May increase siya og 0.12 mm. Kaya positive man siya. So therefore, ang ato ang final length would be 1,500.12 multiplied by the final width. What is the final width? Ang ato ang width is mi-decrease siya og 2.56 times 10 to the negative 3. So therefore, ang ato ang final width is equal to 100 minus 2.56 multiplied by 10 to the negative 3. Kimo may deformation, may gamay man siya. So what is the final width? 100 minus 2.56 times 10 to the negative 3. That is equivalent to 99.99744. Then for our change in height, so our final height in this case would be 50 minus 1.28 times 10 to the negative 3. So you don't have to do this gida. Ako lang siya ipakita ninyo nga mo nang ato ang volumetric strain. So that would be 49.99872. So therefore we have here your 99744 multiplied by your height, which is 49.99872. 49.99872. So therefore, what is the final volume? It would be 15.12 times 99.99744 times 49.99872. That would be 7,500,215.974 cubic millimeter. So that is our final volume. Now, what is the initial volume or the VO? That would be 15 multiplied by 100 multiplied by 50. So what is our final initial volume? So 15 times 100 times 50, that is equivalent to 7,500,000 cubic millimeter. So based pa lang diri sa figure nila duha, kabalo ka nga may increase ang ato ang volume from 7,500,000 to mahimo siyang 7,500,215, or imo siya i-round off, ni increase siya og 216, which is na-solve na to siya sa ato ang volumetric strain gamit lang, right? Gamit lang ang volumetric strain. So therefore, our change in volume is correct. That is 216 cubic millimeter. So therefore, ako lang siya ipakita ha. You don't need to do this. The purpose of this is pa ako nagipakita sa inyo nga ingano siya pagka-solve. Okay? So that is our volumetric strain. So let's check if we have the same answer. Okay, so we have 0.12 for our change in L or change in Z. Your deformation at W or deformation at X is 2.56 negative and negative 1.28 times 10 to the negative 3 ang deformation sa ato ang Y or sa atong height. Sorry guys, that is not E. Dili na siya E. That is change in V dapat na siya because E is dilatation. So wrong na siya. Dilatation na siya ang E. So dili dapat na siya E. So that should be change in V kani. That should be change in V is equal to 216 cubic millimeters rather. Okay, so I hope nga klaro ra. So medyo taas-taas na kaya itong discussion. But anyway, let's proceed with our next problem. Okay, so ang atong topic ganina is all about your uniaxial stress, meaning the body is only experiencing one force on the other side, tapos yun lang, tapos the rest of the strains is due to the effect using Poisson's ratio, di ba? And now, ato next topic would be multiaxial stress, meaning in this kind of situation, all axes has their own stresses, meaning na ay stress sa X, na ay stress sa Y, na pag-stress sa Z. So therefore, we cannot use the previous formula na for uniaxial stress. Nga naman, because all stress will affect all lengths. Diba? So for example, the total strain in X, diba? Natay strain din ni X. The total strain in X is not just caused by the stress ni X pod. Dili lang. Napa na siya'y strain due to the stress at Y and the strain due to the stress at Z. Then so on and so forth. Sa Y pod mo gihapon. Diba? So meaning, a strain on an axis is mainly caused by three stresses acting on the body. So isa ka longitudinal, for example, si X imuhang concern. So kung si X ang longitudinal na pagod siya lateral si X si Y o si Z. So tulo ka stress ang imuhang gina-analyze. Okay, so let's just derive the formula for this one. Okay, so say for example, we have your natitulo ka stress, di ba? Natitulo ka stress. We have your stress at X, right? Stress at X, we have your stress at Y, and we also have your stress at Z. So the same material mo gihapon ni sila, the same material. So we have a single value of our modulus of elasticity. So let's say force, what do you call that? Strain at X dimension. Diba? So whatever dimension nga naa ni X, ato i-compute ang iyahang strain. Okay. So natay tulo, diba? That is mainly three stresses ang mag-occur sa strain, ang mag-cause of strain sa X direction. So first is due to stress at X. Obviously, the strain is just simply using your what? Hooke's law lang na siya. That is just simply using your Hooke's law. Direct lang na siya. That is just simply the stress at X divided by your modulus of elasticity. So, mala na siya. Due to X. Kaya X dimension man na siya. Second, due to stress at Y. So, how are we going to determine the stress due to your stress at Y? Or the strain due to the stress at Y? We can derive that using your Poisson's ratio. Our previous discussed, di ba? Poisson's law or Poisson's ratio. So, ano ang magagamit ng Poisson's ratio? Di ba si EX is just simply, in this case, manggod, alright? In this case, manggod, due to X, due to the stress at X, si X dimension is the longitudinal. Kay X good, home court guna niya, alright? So, home court guna niya. So, therefore, the stress at X is the longitudinal. So, meaning, direct ka diretso. But due to Y, si Y karon is X dimension ta, X dimension. So si X dimension karon is the lateral dimension of your stress at Y. Kay si Y man ang iyahang Y dimension man ang iyahang longitudinal. Kagets? I hope mo na kagets. So therefore, your X now would be your lateral strain, right? The lateral strain due to your stress at Y. So, if nagtalk ta og lateral, ang atong magpalaban ng tadiri would be your Poisson's ratio. Nga naman, di ba if your EX, Poisson's ratio daw na to is your V is equal to negative, your negative of your lateral strain over your longitudinal strain. So therefore, that would be negative. Your lateral strain is equal to negative V times the longitudinal strain. In this case, in this case, ato ang due to Y, due to the stress at Y, ang ato ang longitudinal strain would be equal to your Y over your E. Diba? Because again, ang ato ang longitudinal stress is si Y manggod. So muna nga delta Y ay sigma Y over your E. So to solve for the lateral elongation or lateral strain sa x-axis, you just have to use your Poisson's ratio. So that would be negative V, diba? Negative V multiplied by the longitudinal strain, which is Y over E. Diba? So, the same gyapon. 3. Due to stress at Z. Ang imo gyapon gamiton diha is si Poisson's ratio. Nga naman, mao gyapon. Your X here would be a lateral strain na siya. And ang ato ang longitudinal strain diha would be your Z over E. Di ba? Kabantay mo. Kung x dimension man ta ato gina-consider. So x dimension siya mahimong longitudinal kung x. Pero sa y ug z lateral lang siya. That is why we are going to use your Poisson's ratio. So therefore this would be the strain at z is equal to negative v multiplied by your stress at z over your E. Di ba? So muna siya, tulo ka stress ang ato ang gina-analyze. So therefore to summarize, what is the total x. What is the total strain at the x dimension? So therefore, that would just be due to the due to the stress at x, so that would be sigma x over E. Then the lateral strains, that would be negative V delta sigma y over E, then minus V sigma z over E. So I hope mo nakagets explanation ani, right? Derivation para ako man god before sa when I was still studying, mas dali ko makinumdum sa formula if I derive it. That is why I usually share the derivation kay basin na iuban estudyante nga the same pod, right? Mas dali maka-gets if kabalo ka mo-derive. Okay, so therefore, this would be your sigma, your strain at x is equal to, di ba common man si E, so I'll just have to factor it out. So this would be 1 over E. This would be now your sigma x minus your Poisson's ratio multiplied by sigma y minus your Poisson's ratio multiplied by your sigma z. Now, diri na pod, your Poisson's ratio is a common factor. So I'll just have to factor it out again. Right? So this would be your Poisson's ratio multiplied by your sigma y. Sigma y minus sigma z. So this is the formula in finding the total strain at x due to the multiaxial stresses on a material. So natay stress at x, your strain at y, and your strain at z. So using the same derivation, makakuha kag pattern diha. Alright? The same gihapon nga derivation imo sa tagsaon mag y dimension na pud ka. So mahitabo, right? Ang mahitabo ani ron kung mag y dimension ka kani mahimong lateral, kani mahimong longitudinal, kani mahimong lateral gyud. Sa z dimension na pud kani mahimong lateral, longitudinal. So therefore, you can derive with this pattern. Pattern na siya if x ganin ni siya dire. Oops. Ang pattern nimo karon diri, if you are solving for the x, diba? Strain man is strain at x. So strain at x. So therefore mag-una diha is si stress at x. Alright, si stress at x. Kaya nga naman ang iyang summary ani would be the longitudinal ni siya. Then the other two would be your lateral. Diba? Kaya kung x ka, obviously si x mahimong longitudinal. Ha? So, if x na siya, x would be your longitudinal. longitudinal. Basta, man na siya. So, your y and z would be your lateral. Diba? Your lateral. That is why mas mo prefer yung word nga axial kumpara sa longitudinal yung maglibog ko. Anyway. So, if you are solving for the strain at y, okay? Para mas dali mo duman. Y ang imuhang strain nga gipangita. So, therefore, si y po ang imuhang longitudinal. So, therefore, mahimo ni siyang the stress at y. Then, ang nahabilin, obviously, mahimong lateral. So, this would be x and z. Then, the same also for y, for z. That would be 1 over e multiplied by z man siya. So, therefore, this would be z minus nahabilin. That would be y. Ay, sorry, plus na siya. Plus. So, pwede na siya magkabaylo-baylo. This would be your strain at x. Strain at y. This would be your strain at z. Okay, guys. So, at this point, medyo taas-taas na gud siya. Kaya napatay mga examples. Pero, just bear with me. Sayon lagi ka ni siya. Actually, mas nindot siya if makabalo mo ani. Right? Nindot siya sa feeling na nakabalo mo ani. Wala lang. Nindot lang siya. Okay. So, this is the formula in finding your strains at the 3 axis using your multi-axial stress. Okay? So, muna siya. Let's go back with our PowerPoint. So, therefore, we have here the formula as derived. For EX, your strain at X is malagi hapon na siya. Malagi ito, okay, ingon. This would be your This would be your kaning nauna diri. That would be your longitudinal. And then ang kaning naay Poisson's ratio nga tapad. This is your lateral. Diba? Your longitudinal based on derivation, that is based on Hooke's law lang gina siya. But for the lateral direction, isang atong gina-apply diri is na ay Poisson's ratio. That is why nga natay always nga Poisson's ratio tapad, di ba? Because that is based on the derivation. So I hope nga klaro ra gyud na siya. Okay? So for example, a short solid cast iron cylinder is subjected to axial and radial compressive stresses 40 megapascals and 10 megapascals respectively. So we are going to use E 100 GPa. Your Poisson's ratio is 0.25. Your diameter would be 120 mm. And your L would be 200 mm. Okay. So in this case, in this type of problem, you are going to select, right? Mamili jud ka kung kinsa imuhang longitudinal. Okay? Mamili jud ka kung kinsa ang imuhang longitudinal axis. So, not really mamili. You identify, right? You identify. So, let's proceed with our solution para mas dako-dakog space. Okay. So, if you have a graph or if you have the this problem, the first thing that you need to identify is kung kinsa si example, x, y, and z ba? Imo siya ibutangan og x, y, and z. So, x, y, and X, Y, and Z. Diba? You have your lengths and you have your stresses or force. Kung force ang given, so force. Pero diri nga problem, since stress may gipangita, given, so stress imuhang ibutang. So for example, let's assume lang, okay? Mo na ang pinakaunang nga procedure. Let's assume that x is ang ato ang length. Alright? So, for example, ang atong x nga length would be 200 mm. Diba? So, 200 mm. Therefore, ang ato ang y and z are the diameter. Since rad man ni siya, diba? Kung cylinder na siya, ba't ipasabot, ang ato ang lateral dimensions are equal to the diameter. So, therefore, atong y would be 120 mm. Same here, 120 mm. Now, what is the force or what is the stress acting on the x direction? So, axial. So since nag-assume man ta that the length is 100, so ang atong nag-act diha nga force is si kinsa. Ang ato ang force diha nga nag-act would be your axial compressive stress, that is 40. Negative 40. So nga no negative 40 man? Because again, that is compressive. So negative 40 MPa. Now, radial compressive stresses, meaning palibot siya. If this is your circle, for example, cross-section na siya, naadiha ang ato ang naadiha ang ato ang stresses palibot, alright? Palibot siya. Murag, kung ang cylinder ni mo kani, for example, imo na siya ginakumot, alright? Mayo ang mga boys, ana. Okay. So, that is your compressive stresses or radial compressive stresses. So, therefore, ang ato ang Y and Z are experiencing, since radial man na siya, meaning palibot, so equal na siya all throughout your lateral axis. So, that would be negative 10. Then, negative 10 po dire. Okay, so let's start solving your since ang nagpapakita is change in length man, so we need to solve for the strains. So, let's start solving your strain at X. Diba? So, formula gihapon, that would be 1 over E. Since X man siya, so this would be sigma X minus your Poisson's ratio, delta Y plus sigma Z. Ano delta? Okay. So, this would be equal to 1. Ako lang sa siya tantangon. 1 over pila atong E. That's 100 megapascal. That would be negative 40 minus Poisson's ratio is 0.25. And then negative 10 minus 10. So therefore, what is our strain at X? That would be 1 over 1,000 times negative 40 minus 0.25, negative 20. That would be negative 3.5 times 10 to the negative 4. Now, how about your Y? So, in this case, since cylinder man ni siya, alright, since cylinder man ni siya, ang ato ang strain at Y and your strain at Z are both equal. Kaya same dimension, same stress, so equal ang gihapon na siya. So, therefore, that would be equal to 1 over 100,000 multiplied by our bisag asa. Since barya man na siya, so that would be negative 10 minus negative 40 minus 10. So that would be equal to negative 50 man na siya, no? 10. So that would be positive 2.5 times 10 to the negative 5. So meaning ang ato ang length is mimubo or mi contract. Ang ato ang diameter is ni dako or milapad. So therefore, we can now solve for the change in the first question. The first question is the change in length. So therefore, your EX is simply your change in length over your original length. Therefore, your change in length is equal to what? That is negative 3.5 times 10 to the negative 4 multiplied by your original length, which is 200. So what is our change in length? That is negative 3.5 times 10 to the negative 4 multiplied by 200. That is equal to negative 0.07 mm. Now, how about your change in diameter? So, your change in diameter is, since matawag yung ganina, equal naman na sila maski si strain at Y at strain at Z imong gamiton, equal lang din na siya. So, mamili ra po kanila bisag kinsa since equal naman na siya. So, therefore, your, say, for example, your change in Y is equal to your change in diameter over your original diameter. So, therefore, your change in diameter is equal to 2.5 times 10 to the negative 5 multiplied by the original length, diameter would be 120. So therefore, your change in diameter is equal to positive 2.5 times 10 to the negative 5 multiplied by 120. That would be equivalent to positive 0.003 millimeters. So, midako siya. Okay? May increase kay positive man siya. Now, determine the dilatation. So, we are going to solve for your E. That would be equivalent to your strain at X plus your strain at Y plus your strain at Z. So, that would be strain at X is negative 3.5. Negative 3.5 times 10 to the negative 4. Plus, we have here duha. Duha ka 2.5 times 10 to the negative 5. Diba? Ano duha man, sir? Because your Y and Z are equal, so kung siya times 2, that's 2.5 times 10 to the negative 5. Negative 5 ba? Negative 5. So therefore, our dilatation is equal to negative 3.5 times 10 to the negative 4 plus 2 times 2.5 times 10 to the negative 5. So that would be negative 3 times 10 to the negative 4. That would be our volumetric strain. Now, to solve for the change in volume, we are going to solve for the original volume. Okay, change in volume over the original volume ang guna siya. So, therefore, your change in volume is equal to negative 3 times 10 to the negative 4 multiplied by the original volume. So, what is the original volume? That would be your diameter. That would be 0.25 pi. Diameter is 120 squared and the length is 200 mm. So therefore, your change in volume is equal to negative 3. Negative siya, no? So therefore, mi gamay ang ato ang volume. Negative 4 times 0.25 pi multiplied by 120 squared times 200. Therefore, our change in volume is negative 678.584 cubic millimeter. Okay, so that is how you solve your multiaxial stresses. So let's check if we have the same answer. So first is the change in L is negative 0.07, so may gamay. Your change in diameter is 0.003 millimeters, so then mas may dako. Your dilatation or your volumetric strain is negative 3 times 10 to the negative 4. Therefore, the volume decreased. So, sabtunan man siya ang iyang change in volume is negative 678.584. You can derive the same sa kung example ka ganina. You can derive, alright, kung sakto ba yun ang change in volume is negative 678 by computing the final volume and computing the initial volume, tapos in-subtract lang siya. So, that would be your change in volume. Okay. So, let's proceed with our, I guess this would be the last example. So, determine the change in diameter, axial and radial compressive stresses. So, siguro the same concept na magiging sa hindi na ako siya i-solve kaya medyo taas-taas na kayo siya nga video. So, actually, the same lang siya nga process. Okay? The same process lang ni siya sa ato ang previous nga example katong ganina. Sa example 3.4. So, I guess kaya na ninyo siya. Ang ako lang dire is kaning determine the axial rigidity of the cylinder after loading. So, I would like to emphasize the word after loading. So, first is you are going to okay, so muna ang answer. So, you just have to derive na lang kung yun sa pag-come up. Alright, yun sa pag-come up. So, ang axial rigidity, ang iyang formula diha is your area multiplied by your modulus of elasticity. Dara. Your AE. Pero take note niya, ang iyang gipangita is after loading. So, therefore, you are going to solve the area after loading. Meaning, ni-contract na siya or mi-elongate na siya. So, nanatay strain nga gina-consider. Okay? So, masolve din ninyo siya this example. And then after that one is I have this assignment. So your assignment will be due this Friday. So I'll just be posting that in your VSQEE. So the same procedure for last sem. So sa mga wala pa ka-experience, just follow the instruction as posted. Alright? So determine this, you solve this problem. Okay? So prepare for your assessment this Thursday, that's May 20, until Friday, May 21. So the coverage is whatever that we have talked in this video. Okay? All the topics that we have discussed in this video, that would be the coverage of your assessment 4. Alright? So medyo sayo na siya. Right? Sayo na gid siya. If nakagets. Okay. So that would be the end of our module. So I will be releasing again your problem set. So wala pa ako release sa previous nga module nga problem set. So medyo basiniusan na lang ako. So extended na lang ang deadlines. Alright, so I guess that's the end of this video. So see you on the next video. So buyers.